Good morning. Myself Dr. Dushyant Pradeep, and you are here for physics classes by Dr. Dushyant. And today's topic is uses of dimensional analysis. In general, there are three uses of dimensional analysis. Simply you can say three uses of dimensions. So the most important use of them is you can check the correctness of a relation. Or equation of physical quantities. Check the correctness of a relation or equation of a physical quantities. Number two, you can change the system of units. Means you can change the system of unit from one system, that is from CGS to MKS, for example, from MKS to FPS and such as. And third one, you can derive a relation, or simply you can say a formula for a physical quantity. For example, you can derive this thing. We have learned this F is equal to ma from Newton's laws, but with the help of dimensional analysis, you can derive this F is equal to ma. Now, let's see how we can get the uses of these dimensional analysis one by one. So first thing is how we can check the correctness of relation. For checking the relation, and even in the next uses, we are going to use a principle of homogeneity. That is a very simple principle, but it is very much important for understanding the uses of dimensional analysis. According to this principle, when you are going to have three algebraic terms, plus, minus, equality, addition, subtraction, and equality. Between any two physical quantities, then those two physical quantities are already having same dimensions. Are you getting me? Means if it is A plus B, C minus D equal to F, then A and B, they are related with plus, C and D related with minus, E and F related by equality. These A and B has same dimensions. C and D are having similar dimensions. E and F are having similar dimensions. This is as per the principle of homogeneity. Now, sometimes we are going to have some doubts. In spite of having single term equation, sometimes we can even have an equation of two terms. So, E, the dimensions of E, they're equal to the overall dimension by uniting F and G. Means E की जो भी dimensions हैं, वो F और G को जोड़ने से जो डायमेंशंस बनती हैं वो दोनों डायमेंशंस इक्वल होनी चाहिए. दैट इज योर प्रिंसिपल ऑफ होमोजेनिटी. अब हम इसी प्रिंसिपल को यूज करेंगे फॉर गेटिंग द करेक्टनेस ऑफ एनी रिलेशन. लेट्स सी. We know there is an equation of motion. V is equal to u plus at. It's a very familiar. equation. We have already studied in our previous chapters, the 9th and 10th for motion. यहाँ पे देखिए VUAT, आपके पास 3 टर्म्स हैं. फर्स्ट रिलेशन जो मैंने आपको एग्जांपल दी थी A प्लस B, वो यहाँ पे यूज हो रहा है. और थर्ड रिलेशन जो आपको मैंने एग्जांपल दी थी E इज इक्वल टू F, वो यहाँ यूज हो रहा है. बट यहाँ पे F खुद कंपोजिट है. यहाँ पे F, यहाँ E है V, और ये पूरा का पूरा आपका बन रहा है F. इस पूरे की डायमेंशंस इस के डायमेंशन के बराबर होनी चाहिए और होंगी. दैट इज योर प्रिंसिपल ऑफ होमोजेनिटी. लेट्स सी, V क्या है? वेलोसिटी. इट्स डायमेंशंस आर m0, l1, t minus 1. Now what is U? Same velocity plus A is acceleration, m0, l1, t minus 2. And what is time? It is t. Fundamental quantity, so we are simply using t for it. Now combine them. It is going to give me what? m0, l1, t minus plus m0, l1, t minus 1. Now look at the equation. This is what your principle of homogeneity says. This should be equal to whole of this. Firstly, come to this. ये दोनों सेम है, मीन्स प्रिंसिपल ऑफ होमोजेनिटी क्या है, ने सीखी कहा उसके अकॉर्डिंग ये पार्ट ठीक था. ये दोनों m0 l1 t minus 1 है, तो ये भी m0 l1 t minus 1 है. So according to your principle of homogeneity, this equation, which is very popular equation for motion, that is true as per our correctness. So this was the first use of dimensional analysis. In the next lecture, we will study the next 2 uses. So सब्सक्राइब कीजिए इस चैनल को, लाइक कीजिए, so that we can connect properly, comment, give feedback. Have a great time and subscribe and like physics classes by Dr. Vishnu. Have a great day. Thank you.